So let's take a moment to review the concepts. And keep in mind, these are concepts. These are big ideas. These aren't vocabulary terms that you should necessarily have to cram for before the test. These are ideas that you should understand. Now, what I'm going to do is I'm going to go through these questions that kind of give you an idea of what you should understand at this point to be able to understand physics. And because you have your first unit test coming up very shortly, these are the things you need to understand. And if there was something you're missing, here's your chance to kind of get things cleared up. First of all, what makes a quantity a vector instead of just a number? The big difference for us in physics and using vectors is that it has a directional component. Vectors are not just a how much, a how far, a how fast. It's also whatever quantities going or being applied or moving a certain way. And vectors we are going to continue to use all throughout physics. So it's a very important concept for what we're going to be doing this year. Speed and velocity. Speed is just how fast. You're going 75 miles an hour, 25 miles an hour, whatever. It tells you nothing about physically where you are going. Velocity is how fast and direction. I'm going 25 miles an hour north. I'm going 55 miles an hour southwest. I'm going 35 meters per second at an angle of 23 degrees. Velocity is a vector. It has a number component, and it would have some kind of direction. And in this case, which is where we're going next, your direction can be stated by, an angle measure, or it could be just a direction, due north, south, to the left, up. What does the slope of a position time graph represent? That's velocity. How fast are you moving over a given period of time? It's how far are you moving in a certain period of time? That's what velocity is. What does a negative acceleration represent? Now, I know most of you are going to say this. That is not correct. A negative acceleration does not mean you are slowing down. A negative acceleration means that velocity is changing in the negative direction. That means that however velocity is changing, remember these are vectors, they have a directional component, that velocity is changing in whichever direction we associate to be negative. So think about it this way. In something in free fall, that's the acceleration. Well, it's a negative number. That just means we're associating the negative direction with acceleration going that way. It doesn't necessarily mean you're slowing down, because if you're in free fall, you have a negative acceleration, but you're certainly not slowing down. You're speeding up, but you're doing it in the negative direction. What is the difference between a distance and a displacement? Distance is a number. Displacement is a number and direction. Displacement is a vector. It's how far you are from some reference point and in what direction. I'm 2 miles north of where I started, or I'm 100 meters west of where I started. A distance is merely just the how far part. What does it mean to be in free fall? It all has to do with gravity, and that is gravity is the only thing changing the motion of the object. Now, what does a negative velocity mean? A negative velocity just means that you are moving in the negative direction. doesn't mean you're going backwards. It doesn't mean you're slowing down, because a slowing down is acceleration anyway. Remember that all of these quantities in physics, the positives and negatives, are going to indicate direction for us. So a negative velocity just means you are moving in the negative direction. How can you have an acceleration when your speed is constant? Remember, acceleration is change in velocity. Well, what is velocity? Velocity is speed and direction. So your speed could stay the same. If your direction changes, your velocity has changed. Any change in velocity is by definition an acceleration. So going in a circle on a track like a race car, even if the cruise control is set at 55 miles per hour, they are constantly accelerating because their direction is constantly changing. So describe acceleration in your own terms. We just did it. Acceleration is any change in velocity, which we know is speed and direction. Okay. What is true about the motion of an object if the velocity and the acceleration have opposite signs? Well, keep in mind what signs tell us. Signs tell us direction. So if velocity and acceleration have opposite signs, that means velocity is going in one direction, acceleration is going the other. Now, what does that mean about the motion of the object? This is a case where we would say an object is slowing down. And now it doesn't matter, even if we're in, if you think about something in free fall, as you're moving up, the velocity is going that way, but the acceleration is going this way. They're opposite one another. The acceleration is going to work against the velocity and slow it down. When you get over here, your velocity is now going down. Your acceleration is also, well, now they're working together. They have the same sign. And in that case, they would be speeding up. So the slope of a velocity time graph represents what quantity? Well, if we got velocity in time, how much is velocity changing over time? That is the definition of what acceleration is. What is the y direction velocity of an object that is at its highest point? So something that's going up in the air, it has to stop and turn around and come back down at its highest point. Velocity in the y always equals 0. It has to, because it's going up, it stops, turns around, and comes back down. So anytime you change direction like that, you have to stop going one way, start coming another. Your velocity at that point is going to be 0. What causes the acceleration due to gravity? Well, for us here, in most physical circumstances, it's going to be the mass of the Earth, because we're on the Earth. But basically, the mass of any object exerts a force on another object that we quantify as gravity. And obviously, the Earth is the biggest thing around, so it's what pulls on every other object and accelerates objects towards its center of mass. So why is acceleration due to gravity a constant value? Well, because for all practical purposes, the mass of the Earth is constant. If the mass of the Earth causes the gravity, the mass is constant, so the acceleration due to gravity is going to be constant. Describe an object moving through the air that would be in free fall and one that wouldn't. Well, free fall could be anything that's dropped or thrown through the air. One that wouldn't would be something that has something besides gravity changing this motion. For example, an airplane, a rocket, anything that has an engine that causes its motion to change, and it's not just gravity, that would not be free fall. Some appropriate units for acceleration, well, is any unit of velocity over a unit of time. Meters per second is a unit of velocity. Meters per second every second, or meters per second squared, that makes a unit for acceleration. Now, miles per hour can be a unit of velocity. Miles per hour per second. How many miles per hour are you changing your velocity every second? That would be another unit for acceleration. Kilometers per hour per second. Kilometers per second, or kilometers per second squared. These are all acceptable units for acceleration. So we got a bowling ball and a ping pong ball dropped from the same height. Describe their resultant motion. Okay, so what's going to happen to the motion of the bowling ball and the ping pong? If they are dropped, well, they are both going to move towards the earth because gravity is going to pull them down. They will both be accelerated at a rate of 9.81 meters per second squared, because if they are dropped and neither one of these things have an engine to change their own speed, they are both going to be accelerated by gravity at the same rate. So if I drop them both from the same starting speed, 0, and gravity works on them the same and changes their motion the same going down, their resultant motion, they will have the same velocity at all times. They will hit the ground with the same velocity. The time it takes one to hit the ground will be the same as the time it takes the other to hit the ground, because what's making it hit the ground is gravity. And gravity is the same for the ping pong ball as it is for the bowling ball, because we talked about it up here. Gravity is a constant because the mass of the earth is a constant. So we got in number 18, a physics teacher is fired vertically into the air from a cannon, probably from a frustrated physics class. Describe all you can about the teacher's motion from start to finish. So we got poor physics teacher shot up into the air out of a cannon, has some initial velocity in the y direction. Now, what's happening here to the teacher going this way? Here, the acceleration is negative, but the velocity is positive. They work against each other. So from here to here, the teacher is slowing down. At some point, the teacher reaches its max height where the velocity is 0, at which point the teacher starts to fall back down to the ground. Well, what's happening from here to here is the teacher is accelerating at that rate. Well, that teacher had the same acceleration going up because it's caused by gravity. The difference here, when the velocity is positive and the acceleration is negative, you end up slowing down. Now as you come down, the velocity is negative and the acceleration is negative, so they're working together. You are speeding up. The time to go up would equal the time to go down. Because remember, as soon as the physics teacher leaves the cannon, gravity is the only thing changing the motion. So if gravity takes 10 seconds to slow the teacher down to here, gravity is also going to take 10 seconds to pull the teacher back down. The initial velocity up is going to equal the final velocity going down. Your velocity right here coming out of the cannon is going to be equal to the velocity with which you hit the ground, because you have a velocity of, let's say, 100, and gravity is going to slow it down to 0. But then gravity is going to change it this way the same way it changed it this way. So here it was slowing it down from 100 to 0. Because gravity is the same, it's going to speed it up from 0 right back to 100. Once again, This is why you should never fire a gun up in the air, because the bullet firing out the end of the gun, when it comes right back down, it has the same speed it had when it left the gun. And obviously, you don't want to get shot with a gun. So because gravity works the same way going up and going down, the starting speed going up equals the final speed coming down. Now, how would this be different if this was on the moon? Well, if this were on the moon, has less mass, which equals less gravity. So if gravity isn't pulling back on the teacher and slowing the teacher down as much as they're going up, and let's say it's the same cannon, the teacher is going to take longer to slow down because that number is going to be less. You're going to be accelerating at a lower rate. So the teacher is going to go up for longer, going to reach a higher point, and then it would take longer to come back down. The speed at which the teacher hit the moon would still be the same. Because remember, in free fall problems, being fired out of the cannon at whatever speed is the same speed you're going to hit the ground with. So it wouldn't matter on Earth or the moon, you're going to start and end with the same velocity. Now, the difference is it's going to take you longer to get to that velocity because you're going to be up here before you turn around and come back down. But it also means you're falling farther for more time. And the moon's gravity has more time to speed you up. So the acceleration is different, but you still wind up doing the same thing. It just takes longer to happen because, remember, acceleration is a change. The moon isn't going to change your speed as much as the Earth. Now, how would it happen differently on Jupiter? Well, Jupiter has more mass, which means the value for gravity is going to be a lot higher. So the same cannon isn't going to fire you up as high because as soon as you come out of the cannon, gravity is really slowing you down on Jupiter. And then it's really going to speed you up. So the trip for the physics teacher wouldn't be nearly as long. But the teacher hits the ground in Jupiter at the same speed as you would hit it on the Earth or on the moon, because that final speed was caused by the starting speed of the cannon. Now, on Jupiter, what's different? It'd be a really quick trip because the acceleration due to gravity on Jupiter is so much bigger than the Earth. I mean, I'd hardly get out of the cannon before I come right back down to the ground, and it would be at the same speed. So if you have any questions, if there was something on this you didn't understand, or as you were listening to me explain it, you had, I wonder, well, what if, or that, or ask the question. Feel free to email me the question, write these down, bring it up in a class discussion, and we'll talk about it.